have to be on. I need you guys to be able to see me. Okay, really quick. I want to do, there's a small little part of 7.1 that we haven't gotten to yet. And I really was just waiting for us to come back in person today to do it. And then guess what? We didn't come back in person today. So this is just a quick 7.1 continued. If you remember, 7.1 dealt with both sequences and series. Okay, so in a sequence, you would have seen something like the following. You would have had maybe 5, 6, 7, 8, 9. And that would have been your sequence. This would have been like an A sub n equals this. Okay, this is in fact a sequence. So we've done sequences. That's what we've done for like 4 days straight now. What we haven't done is a series. So one quick little detail change about this turns us from a sequence into a series. So that first detail would be sequence has commas in between each term. A series has addition signs in between each term. So to take this from a sequence to a series, you simply put addition in between the terms instead of a comma, okay? So now I actually have a series. If you remember though, we've done this example before. The rule that we wrote for this was that a sub n equaled n plus 4. Okay, and that makes sense because here n is 1, you add 4 to get 5. Here n is 2, you add 4 to get 6. N is 3, add 4 to get 7, and so on. So this was our rule, okay? What I'm going to show you now is how to put this into something called summation notation. So in summation notation, we have an uppercase sigma. That's this weird looking E thing. It's called an uppercase sigma. On top of this is our upper limit. That basically says how many terms do you have in the series. And down here, we do our starting term. So here, how many terms in the series? Here, what term are you starting at? Because just because there are 5 terms in the series doesn't mean I have to include all 5 terms in my summation. I could say, we'll start at term 3 and just do then 3, 4, and 5, okay? So when we use summation notation, it truly is to actually, 1, find the series, and 2, add the series. Notice there's just addition between all of these, so you can find the actual sum of the series. That being why we say, well, what's our last term in this, and what's our first term? Because that's going to depend on what the actual sum is. If I say, yeah, do 1 through 4 or 1 through 5 terms, that sum is going to be different than if I tell you do 1 through 3 instead. Okay? So upper limit, starting term, and then your rule goes right here. So whatever the rule is for that series, you calculate or not calculate, but you find the rule just like you would in a sequence. This is your first term, n is 1, second term, n is 2, third term, n is 3, and so on. You find this rule exactly the same for sequences and for series. So if you're not super strong at that, definitely go back to a couple days prior and work on some of those examples. Okay, so let's really quick write the summation notation for this series. So when I go to do that, I have to do my uppercase sigma, funny looking E. You'll probably be horrible at writing it, and that's totally okay. So then my upper limit is stating how many terms am I including in this series. So I have 1, 2, 3, 4, 5 terms. So upper limit, number of terms, is 5. And I just put a 5 up on top of that sigma. And then what's my starting term? Well, I'm starting at term number 1. So I'm going to down here say, yep, n equals 1. You're starting at that first term. Then the rule that I wrote for this was n+4. So that rule goes right here. That's your summation notation. Okay? From here, if I have only summation notation, I should be able to write this series using just that information. We're going to do that in just a second. Okay? But this was taking a series and writing it as a summation notation. Is there any questions on that? Awesome. All right. So now let's go the other way. I'm going to give you a rule and I'm going to have you write out the series. Okay, so I'm going to give you the summation notation. That notation is n equals 1, and let's do upper limit of 4. Okay, and I want you now, oh, I actually have to give you a rule too. Let's say 2n. That's going to be our rule. Okay, so this is the summation notation. I want you to write out the series for this summation. So to do that, we will end up having 4 terms. How do I know that? My upper limit is 4, and I'm starting at term number 1. So I have to write terms 1 through 4 going on here. So the way we do this is simply plugging in our n to our n value. We start at 1, so I'm plugging in 1 for n. So my first term would be 2 times 1. Okay, now my n is 2 in this second one, right? So n was 1 here. Here n equals 2. So I'm putting in 2 for n. Here n is 3. So I'm putting in, oops, I don't know why I wrote n there. I'm putting in 3 for n. And lastly, putting in 4 for n. Okay, so if I simplify this just a little bit, I can go ahead and get the summation. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So this is the actual series based on this summation notation. Okay, what if I asked you to find the sum of the series? What do you think you do? Add them up, right? 2 plus 4 is 6, plus 4 is 12, plus 8 is 20. So the actual sum here would be 20. And we don't ask for that every time, but sometimes Grace is not in our Zoom right now, Jackson. She is not in the waiting room. She could possibly be in the wrong one. That would be my only guess. Okay, so backwards. Given the series, write summation notation. Given the summation notation, write the series. Those are the 2 things that we still had left to kind of talk about. Okay, and it's kind of just an intro to using series and summations. Any questions? Okay, what I want you to do then is these 3 problems. So page 438, number 38, 43, and 47. If you're remote, go ahead and turn those into the Google Classroom. Otherwise, you can just bring them tomorrow and we can go over them. Okay, as soon as you